Alright, welcome back generals to another Let's Fix Generals Zero how to make the best game ever. Last video we did do some tweaks to unassemblize tool from the Omniblade. It did generate 200,000 files, which I'm deleting right now because the folder is getting super slow. Plus I have been unable to move it into a subfolder. It just dies. It looks like a Windows Explorer is not made to handle so many files. Yeah. Probably hit some memory limit or something. Something breaks inside the program. So it looks like Microsoft never tested it with so many files, which is a shame. Okay, so but at least we can delete it. That's good, I think. Well, it's still showing. Okay, it's gone now. Very good. Okay, yeah, so I did send it to Thompson's, and he said definitely not a million separate files now. So he doesn't like to have a million separate files. It wasn't a million, it was 200,000. He said would need to add means of defining object ranges. Okay, so he wants to define object ranges and then have fewer chunks. Yeah, so not one file for each function, but one file for a set of functions depending on their association. Yeah. Yeah, then I need from him some sample. Send some sample ranges. Send some samples of what you need, and I can try to implement the functionality for it. Yeah, so it's not very specific. The intel that I get is not specific on this. I mean, I get understanding, but I need some like send a JSON format, like this range, or maybe he wants to say I have this CPP file name and these functions are in there. Like what should be in there? Like I don't understand. It needs to be specific. Okay. Yeah. Okay. So I suspect we need something like ranges.json, or perhaps call it objects.json, or actually maybe it could be part of this file as well, but it's quite big already. Well, this one is generated. Okay, how about we first create a branch and submit what we already have, because it works for what we currently have. So we create branch, split, or generates ASM ranges. I don't know. Okay, so what did we do? Hmm. Hmm. Okay. I think the first thing we need to do is we need to stash. Yeah, that's the first thing. Then we need to fix the format first. I think it's Alt F. No. I can't remember what the formatting options key formatting keyboard formatting. Format selection. Okay, text editor, Control F. Ah, but that's fine. Maybe Alt F. Hello? Alt F. Okay. Shift F. Let's go with that. Okay, so we select this, Alt F. Okay. Alt F. Executable function get opt get info main. Okay. So I think I have updated all of them. Let's say. Okay, so here we do fix Clang formats or update Clang formats on, yeah, just like that. Okay, commit. Then next we do the stash pop, and there's a conflict. Yes. Well, there's no conflict. Let's take that. There's a conflict. We take ours. Okay. Good. Let's see if that compiles. Okay, so let's unstage this. Okay, let's first do the... Oof. Yeah, let's do one thing at a time. Yeah, let's stash this again. And then we go to symbol. Stash. Okay, we open the symbol. Oh boy. Here. So we named it to address, right? Address. Okay, then this is rename symbol value to symbol address. Oh, it fails. Okay. Okay, that's curious why Visual Assist doesn't detect this. Huh. That's weird. Okay. All right, so we got this. Commit. Then we stash pop. And of course there are conflicts again. Oh. Okay, so we need to stage this and amend commit. All right. Okay, next I would say we fix this here. At least I hope I got it all correct. Well, actually, before we do that, how about here we take this fix here. Write sections. So this one is called start, which is not a great name. How about we rename it? Let's search for start. Start. That's not a great name. Start. I hate auto. Auto is it's worst. You can't jump to this. Like if you press, yeah, just goes to some iterator. It's fucking ridiculous. Why do people use auto? It's so bad. One of the worst additions to C++, except for a few cases. Okay, so here we have names. So my suggestion is to rename this to offset. Offset, and then we name it here offset. And again, it did not recognize this. That's weird. Let's call this offset as well. Okay, which then means we need to update our config and call this offset. And then, yeah. And here we can also call this offset. Offset. Oh. Why is this made so complicated here? Just make it just so complicated. This code. Object section, just push back an empty one. Just do an mplace back, yeah. And then push to object sections dot back dot name, right? Or we do here object section, here object section equals this thing here. Okay, and then we simply put that here, section.name, section.offset, and section.size. Good. Then we don't need this pushback here anymore, and we can remove all these things here, and we're done. See, much simpler. Good. STD list is also really bad. Shouldn't use that. Never. Almost never. I've never come across a situation where I needed a list. Can always use vector. Always. Okay, so this should work. Let's compile. Actually, let's put a breakpoint here just in case and test if it actually works still. Yeah. So it pushes back, has a section here, and now it fills it with text and offset and size. Yeah. Yeah. This is working. Okay. Yeah, now I need to get all the right changes for this. So we change this one. Oof. This and oh boy. And we touched this one. Anything in here? sure. Let's see where offset is touched. Yeah. No, it looks like it's only touched and executable. Yeah. Okay, so write actual offset into sections and name it offset. Well, let's say label it. Write actual offset value into into corresponding sections and label them offset. Label them offset. Okay, next. Okay, next we fixed here all these comparisons. Let's do these things. Here, all this, all that. And this stuff. This. Here's more. All right. Function. Well, was there more or not? Executable here. Okay. I hope that's all. Okay, let's call this fix address range conditions. Address ranges conditions. What? Address ranges conditions. Okay. There's that. Okay, and then next we did. Actually, let's stash this, what we currently have, and compile to see if it actually compiles as is. It should. Unless I made a mistake. Okay, that compiles. Good, then stash pop. And then we so here we did some fixing, right? So I guess we can take this. Then we take we take this. We need this. And I think we take all this here. And this. And so what we did here was fix and optimize. Fix and optimize this function. Because the addresses it tried to assemble here before, it was not correct. It led to weird offsets and then it was crashing out of bounds. And now it seems to be correct, right? We also need to take this one. I wonder, does get binary? Okay, but this should be correct here. Okay, let's commit this. Let's stash current state and let's see what actually compiles. Oh, it doesn't. Okay. So we made a mistake. Stash pop. Yeah, I think it's because we have this one here. Okay, let's amend that. Okay, then we stash. Okay, let's try again. Okay, that compiles, stash pop. Yeah, sections. Okay, then I would say we simply, let's open this class here, executable here, and we move this back to where it was before. Section map, get binary, sections. How about we rename it to get sections? Get sections. Let's call it section map. How about that? Get section map. Then we can also rename this to get section map. Okay. We need to save. Okay, let's make one change here. Rename sections to section map. Rename M sections to M sections map. Okay. Commit. Let's stash. Let's see if it compiles just fine. No, it does not. Okay. Get section map. XE. That's an executable. Section map. Map. Here. Okay. Must be const. Okay. see if that compiles. Okay, that compiles. Then we need to amend that. Okay, stash pop conflicts, yes. Open here. Take that, done. Save. All right. Okay, next. Get back to executable. Put back in here our section. No. Symbol map. All right, compile this. And so the last change is all the logic to just dump all the individual files. Okay, add functionality to dump ASM for each individual file function. Have function to dump ASM file for each individual function in config.json. Yeah. Okay, so this is all the changes we did. Now we have here, let's compile. Yeah. Okay, then let's do manage stashes. Drop. Drop. And drop. All right. Okay, let's push that to oof. All right. Good. Then let me your positives. Merge with rebase. Fixes some bugs. Adds functionality to dump ASM file for each individual function in config.json. To dump Good. So I would just I created pull for current set of changes here. Contains Clang format updates, bug fixes, and functionality to dump each function in its own file. Continue this effort or drop it. Unclear to me if you want me to proceed or not. Unclear to me. Yeah, it's as usual, it's a little bit communication is not the best here. There's always more questions than answers. Yeah. So I suspect that they want like a file where you just say, aha, we have this CPP file and it belongs to these ranges, and then have like a whole big definition file for all sorts of ranges, and then you just run this and generate the ASM files for this. But apparently we don't have this. Here he says it won't be a one and done thing. We would figure out object ranges as we work on things. So it looks like it does not exist, which is unfortunate, because if it did, then we could just generate it now and have it. But yeah, okay. So it looks like to me there is no real plan on how to proceed with Thyme. It's a big problem. We are stuck at 52% complete for standalone, but there's no vision going forward now. Like looks like they want to explore more ways of how to achieve certain things, but the problem is that this won't get things done. It just means that there will be some investigations here and there, but we won't process with actually writing C++ code, which I think that's the most important, that we write C++ code. Whether or not it's all 100% complete in the end, that's a different story. But at least if we were at the position where we'd say, yeah, all the code is here, you can start the game, you can load into a map, and it runs in principle, but there are X, Y, Z bugs. I think that is still better than having it, than being nowhere near that, right? That's like if we are not there, then we can't polish, we can't fix things, right? So like at least if you have a finished state, then you can start polishing, fixing, and testing, and figuring things out in all the different ways. Like you can find bugs by just debugging game, right? And then you look at the function and you see that there's a bug, and then you just fix it, right? That's one way. Or you just read the code and you see, oh, this code doesn't make sense, you fix it, right? And then of course there is a way of we want to generate Visual 6 generated assembler out of the code and compare it against the original code to see if it's an exact binary match. Yes, but that's just another way of verification. Like just verify that it's correct or not. That's it. It doesn't get the work done though. It just says if it's correct or not. But it's not it's not mission critical, I would say. So I don't know why this is the focus, but okay. So it's unclear. I need some intel on this. Like, do we go forward with this? Do we focus on this now? What's the plan? I'm missing the bigger picture here. Like someone needs to tell what to do. If someone knows what to do. Unclear. The roadmap is unclear here. Yeah. No idea. Yeah, so what we could do with this tool, we could create a new JSON file, right? Like ranges.json. And then we have something like range name, and then we give it some name, and then start and end, and then we just load it into C++, and then out of these definitions, we then generate the assembler files one by one. And then you can add to these ranges as you go and add more and more and more. Yeah. But then this manual labor required. Okay. Yeah. Yeah, well, it's not clear to me. Like even if we implement all this now, like let's say we have a most amazing tool, will it actually be used or not? This I don't understand. Like, do we actually plan to use these things? Like if we get this done, what is the step afterwards? And if that is done, what is the next step afterwards? Is this laid out? If we don't have a plan, I don't even know if I can ask this. Do we have a full plan from start to finish on how to continue with Thyme now, or from start to finish on how to continue with Thyme now, or not yet? If we do, what should I do next then? Do we plan on using unassemblize tool for development now, or it's not clear. Like, so it's, I don't know what to think of this. Like, what's the step afterwards? What do we do? I don't understand. It's also confusing because like the 52% completion of Thyme currently was done in one way, and it allowed to progress, but suddenly after 52% completion, that is no longer valid. And this I don't understand. Like, why is a procedure that has been working so far and led to like a result, why is this not good enough anymore? Why can't we continue with this approach? I don't understand this. So there was rationale of, okay, it's hard to do. Okay, I see that. Yeah, it's hard to do. Like, this reviewing is hard to do because you have to like manually check if the written C++ code does actually match the logic in assembler. Yeah, so that is certainly not nice to check by hand. or by eyeballs. Yeah, okay, but I mean, the binary matching is just, as I said, a way of verification. It doesn't magically implement anything for us. It would be nice to have like an AI that just generates us pseudo C++ code out of the assembler, and then we can just go from there and fix any little mistakes it makes. But as far as I'm aware, there's no such thing yet. But it would be possible to train such an AI by, if you train the AI, so you tell the AI like if you can always compile one way, right? You can always compile assembler out of C++. So what the AI can do is it can look at the assembler, write C++ code, then it can compile it, generate the assembler, and then compare it against the assembler and see if it matches. If it doesn't match, repeat. And keep on repeating until it matches. And then over time, it would learn all the rules eventually. Yeah. I don't know. I'm not expert in this. Okay. Well, we need a plan here. Okay, looks like Saikana is also looking into things. Not sure what he is doing exactly. So we have PDB dumper. Okay, that's a good point here. So if you manage to create code that then matches the assembler, then you know the functionality must be correct without the requirement of needing to test this, right? You just see the assembler is matching, and you don't care afterwards. Yeah. Yeah. Okay, I need some more intel here. I don't know what to do now. Um, I guess like we need we need to compile Thyme or a version of it with Visual Studio 6. Then it would generate executable, PDB, object files, and then you would take these and then compare it somehow with files we generate off of the original game executable, and then these would be somehow diffable, ideally. Yeah. Okay. Yeah, I don't know what to do now. PDB dumper, perhaps we can take a sneak peek at this thing, what that is. Dump, yeah. See, it allows to dump symbol information. Okay. Dump all symbols, globals. Yeah. Okay. Perhaps. So if we, I do wonder. Hmm. So what we can, how about we run okay, how about we run conf okay, so minus minus start 0 minus minus end this. Yeah. So this should then create one big fire, if I'm not mistaken. Let's see, let's put a breakpoint here. Okay, that didn't work somehow. Why not? Huh? Okay. Something is wrong here. Maybe in the game that needs to be put at the end. Hmm. Okay, that's weird. That works. Okay, so this should then jump in here, yeah. And that's exited really fast. And that doesn't look right. Okay. Start, end. Because it wants start to be not 0 for some reason. But why not? Why can start not be 0? Let's remove this one here. Try again. I would just say starts should be smaller than ends. Maybe. Mm-hmm. Oh, but this will give us section in for now. Section. Okay, let's keep it at not 0 for now. Then, okay, let's change this to 1000 hex. Yeah. Okay, dump. Okay, this should find the text section now, yeah. And but this will read beyond the end. Yeah, so I expect now if we continue it will crash because end offset is well beyond the text size. So we can we Yeah, let's let it run, and I expect it will crash. It didn't crash. Okay, that's surprising. So it generated here a file, which is very small. It's relatively small. Why? We I'm not sure. The end address. Okay, I don't understand why it stopped where it stopped. That's the first. If offset, so this. So. It's probably we probably go over some bytes that are no longer assemble code, but just something that it doesn't recognize it as such, and then this one returns false, I guess. Maybe. It would be nice if we could put a breakpoint when it fails, but we can't. So where did it stop? But down here the stuff doesn't look as suspicious as I thought. Can we write this in a way that we can set a breakpoint? Yeah. We do here. Constable success If not success, break. Yeah. And here while true. Then we can put a breakpoint here. If offsets this, break. Okay, so we split this apart. Okay, I think this is better. We can put breakpoints here. Let's do the same here. Success if that, break if not success, break. Or let's say continue. Success, okay. Okay, and then here while true. Let's also put breakpoints here. Okay, let's see this. So this one returns false at some offsets. Yeah. Instruction is what? Okay. Why is it invalid? Section data. Let's take this thing here. Section data watch. Offset is copy. Section data. Take this offset here. 255. Let's put a comma 2. Let's do section data plus this. Okay, let's put a bit more, 10. So it doesn't recognize these values there. Legacy. Opcode 255. Which is a FF. Okay, what if we just Like if there was no success, how about instead of breaking, we just continue? What will happen then? Like, can we just skip over? I don't know if that's valid. Let's see. Okay, so we hit that here. And now we just continue. Let's see. The next one is also false. Question is, will this ever get past this or not? Ah, hold on. We are not advancing. If not success. What kind of modes do we have here? What happens if we do this one here? Does that change anything? No. Okay, so what if we... So here we say, hey, if this happens, then offset runtime. Let's see what this does. I have no clue. Just try an error. So basically, we just want to skip over this invalid instruction. So let's see if the next one... Okay, the next one succeeds again. Let's see how often this happens. Okay, happened again. Yeah. Well, let's just run it through. I expect it will crash at some point. And it does, because it will run over the buffer, yeah. Yeah, so offset. Yeah, eventually, yeah, that's okay. So the problem is that we can give it a range which is not within the bounds of the actual data, right? So that's not good. What we can do is we can do find section. If we say if and offset minus offset is larger than section info size, then we return because that's out of range. Then I think we can also remove this one here. It's kind of redundant then. Yeah. Okay, so basically we would have to provide a range that is within the section. If it goes beyond that, then it's invalid. So this also means we can only ever disassemble one whole section at a time, because we cannot just go over the boundaries of one to the next. That doesn't work. At least not with the current logic in this function. And I think it's also not necessary. I don't know. Okay, so then what we should do is we say so we have size plus, well, let's do size hex plus 1000. Okay, so this is our end. Okay, so we go to here, properties, and in here we put our end is this thing. Yeah. So we start at 1000 and this, so this is basically the entire text section, right? From start to end. Yeah. Okay, let's put a breakpoint here. Okay, let's get that. Okay, so this one should now always succeed. Yeah, so this is a max. And offset minus this is not larger than this, so we continue. Yeah, okay, this should be okay. Okay, so basically this one should succeed now. If we also put this one here. Yeah. How about we put this condition here in this offset smaller and offset, then we can remove this. Can do the same here. Okay, let's put a breakpoint here. Okay, so this one will jump in there a bunch of times. Certainly more than once. Okay, let's see if it also jumps there at the bottom. Oh, it still crashes. Okay, that's unexpected. Well, it's close to the end. Okay, it's somehow close to the end and then it crashed. Why? If not success, yeah. Okay, I don't know why it crashes there at the end. Yeah, I don't know. It somehow decides that at the end, there's the end. Okay, so let's check it in the watch. So yeah, offset is this. Yeah. Okay. Okay, unable to read memory. What about one before that? Okay. So it's invalid here. Oof. Well, if that doesn't... Okay, let's put a breakpoint in here. Okay, so section data is that. It's good. Virtual address, size, offset. Smaller image base. I wonder if there's an error here. It looks suspicious. Address. I don't understand what the logic is here. Why add image base? Add base. Okay, so we have add base. Then we probably would need to check if add base, only then add and subtract image base at the other place here, where we do this, possibly. Yeah. But then why bother? Why bother with this? Okay, so because different executable formats do it differently. That's why, okay. Oh, we already got a base address. Okay, so base address. Okay, bool add base const return add base. Let's go do add base, and we'll go to function, and here we say executable dot do add base question mark, then executable base address, otherwise 0. Okay, then we can also remove this here. And also the header. Okay. Okay, but that still doesn't explain why it goes beyond the size of the data. Or the data is too small somehow. Like, I don't know. Something is not right here. Data. 538. What is it here? Five, 3, 8. It's the same. Five, 3, 8. Okay, but this seems now logical to me, I guess. Okay, so what's the problem then? Okay, it certainly should not go out of bounds, so I don't know what's up with that. This seems to be a bug in that library. I see no reason why it should be invalid. It is very close to the end though. Very close. It's almost there. Copy. Yeah, okay, but at least it's consistent. Yeah. Okay, I've no clue why it doesn't get to the very end. So I guess what we do is we put this in here and we just don't go to the very end for whatever reason, because it's not safe. It's very suspicious though. Okay, so it did something now. And it generated a very big program. Yeah. So okay, so how about disassembly instruction? Okay, so how about if it's not successful, then we say invalid opcode, and then I don't know, instruction info opcode. Let's put a breakpoint here and see if there's some useful text printed somewhere. I tested range. Tested range. Start this. It somehow crashes. Data is invalid starting at scan that text. So range somehow can only be I also noticed that unasm will fail at various various codes. Right now, this disassemble right now function disassemble just stops execution. I may change to skip over, but not sure if healthy. Okay, so let's put a breakpoint here. Or here, yeah. Instruction coding legacy. Okay, so we have opcode length. Okay, opcode. Legacy. Encoding. I have another question here. Why do we make a first pass and then do a second pass again and then write something again? I don't understand this. What is the difference between disassemble custom and disassemble no format? Like, why does it do it twice? Copy of the disassemble function without any formatting. Let's do a const Zion status. If not Zion success status bye. Status. I do not understand yet why it does pass with this and afterwards with okay, how about we put breakpoints here now, yeah, and we check what actually the status is. Oh, right. Okay, so status is well, it's not really readable. Okay. Oh boy. Well, there can only be this. It's either success or invalid arguments. I see nothing else here. Yeah. But machine mode. But that can't be. Zion check also has. Okay, return. Okay. Okay, so invalids. Executable equals Ah. Basically, I would just like to output some information about this failed assembler. So we have opcode, we have a length. Okay, let's just say invalid. By the way, this is not the correct. Where's the output? I saw it somewhere. Here, disassembly. Ah. Okay, it just starts writing here on the second pass. So. Okay. I should have read the comments here. That one explains it. Okay, so it means we can't write here. Well, we could. Or maybe not. Like this. Invalid opcode address, or let's say unrecognized at string stream. Instruction. Text. Nothing. Operands. Okay, well, if we're using string stream, let's say stream unrecognized opcode at that runtime address bytes and length, well, just bytes for instruction for int info dot length. What is this type? I 0, I smaller that, plus plus I, stream SCD hex, instruction info dot no. Section data offset plus E. Okay, I guess like this. And this assembly plus str. Well, let's try this. Let's see. Stream opcode at okay, stream. Oof. Oof. I think this is not the right. Or is it FF? Is that right? No. It should be a FF then. Huh? Do we have a casted perhaps? I don't know. UN 32 T. Static cast. It's kind of weird though. Let's call this address bytes. Let's put a std string str. Is that so we can read it? And then disassembly. What is disassembly? It's also a string. Okay. Bytes FFFF. Okay, so somehow we have to cast it to 4-byte type, and only then it works correctly. Yeah. Okay, then let's also take this and copy it to the other place here. Okay. Okay, and then we do open, and now it should print a bunch of unrecognized opcodes. Here. If the program starts responding. Okay, let's search for it. Okay, 16,000 hits. 17, it's not that much. Let's do a add runtime address that. Image address image address. How about we put here 0x 0x std hex and then runtime address plus image base plus that. Okay. Okay, then we copy this to the other place as well. Perhaps we should make a single function for this. Yeah, let's put void output hold on. How do we comment in assembler? I think it's starting with a dot, maybe. Comment in assembler syntax. So this is offering me a whole bunch of characters to do comments. How about just one would be enough? Why is there so many possibilities? This or that or this or that. So the semicolon. So this makes other suggestions. Okay, well, then let's put a semicolon. I have no idea. Append unrecognized temperatures. It requires so many parameters. Let's just keep it here for now then. Okay. Okay, let's run this. Oh, that crashed. Oh. Why? What did I do wrong this time? Ah. Oof. Okay, then let's see what our new printing gives. Yeah. Ah, I forgot something again. I wanted to add a line break. std. How do we do line breaks here? Manually, okay. Okay, so stream. Let's just do it here and plus n. I think this program is so slow because of all the STD lists and stuff. Yeah, my suspicion that this is a major bottleneck. I could be mistaken. Okay, let's try this again. Unrecognized opcode. Okay, now this is better. Okay, this is FFF. Okay, I think here it would be good to put a leading 0. Can we do this? STD hex. Oh boy. String stream leading 0 number. Okay, that's way too complicated here. Let's try this then. Okay. It's unrecognized. Ah. So one header for the just this one function here. Sounds about right. Well, let's see. Well, it worked, but it didn't put zeros there. So maybe we need to call this one here. Stream.fill 0. I don't know. Okay, I think this function, this logic gets big enough to warrant a... Okay, well, it works now. Okay, then let's call this runtime address, image address. Let's create a function, void add unrecognized. So we have the string, std string out, or just std string create unrecognized summary. Then we pass this runtime address and instruction ins runtime address, image base, and what else? Let's take this here, put that in, return this. Unrecognized instruction string. So we have runtime, we have image base, we have instruction, and we need section data as well. Let's make this const. Section data offset. Let's call this ins data, and then we do ins data I. Let's put this here to the front. Okay. Then call it here with instruction with section data plus offset and runtime address, image base, and this is let's do str here string equals that str this, and then we remove this, and we did a mistake. We remove this and that and that. Yeah, and put it down here as well. Okay. Okay, so less code duplication because it's quite intense formatting here already. Okay, then let's run this. I think we can also move this into our namespace. Okay, let's see our update here. Okay, that looks good. Now there is some leading white space here, but who cares? Okay. Okay. Unrecognized opcodes. Now let's search for this, find. Runtime address, image address. Okay, Then let's send this to Thompson's and have him eyeball this in case he cares. I don't know if he cares about all this. It's totally unclear to me. But let's just keep digging. I have no clue yet what our grand goal should be, but let's just keep digging here. Good, so we have this. So basically we have now made the program to skip over anytime it encounters an unrecognized opcode and just continue processing the assembler anyway. Before it would just stop and just like stop dumping assembler code when it encountered one unrecognized opcode, which was very early already. So this would mean that we would lose opcodes. And now what it does is it will just print out these opcodes as a comment. Yeah. So hopefully it makes sense. Let's jump to one that is inline and within codes to see where it's placed. Okay, so it's in between functions here. Okay, so I make a log here of this. Yeah, so this is unrecognized opcodes. Good. Then let's zip this up. Okay, and then let's send it. I made improvement to this assemble to no longer stop on first invalid or first unrecognized opcodes. Now skips over it and continues with next. I dump it to game dot with dump tool dot text game from game dot and put list of all unrecognized opcodes. It's 1700 hits. Good. Whether or not they do anything with it, I have no clue, but that's what I have right now. Yeah. I mean, I guess it can always happen that you have an executable and there are some opcodes inside that it doesn't recognize. And then what you do, you just skip over it. Yeah. I mean, if it's just 1700 out of millions of lines, how many lines? Yeah, literally a million. almost 2 million lines, then yeah, I think 1700 out of 2 million is not much. Yeah. Okay. So that's what I have right now. I don't know if it's going into the right direction or not. But basically, I guess if they have just like if you just use the functions from if you just use the ranges from the actual functions, then maybe you don't hit these invalid opcodes, as they seem to sit mainly between things. I don't know. Well, this one is weird. Okay, this one sits definitely within a function. Yeah, that's weird. Yeah. Okay. Well, yeah, I think that's it for now. Again, exactly 3 hours work time. Yeah, very punctual here today. All right, then I hope you learned something. I hope you enjoyed, if that is even possible. Right now, I have no clue what I should do. I guess what we need to achieve is have an assembly output generated on game.dat, but also on whatever we compile with Thyme or Thyme-ng. With Visual Studio 6, and then have like a similar set of things outputted there. And then if we can then cluster this into smaller chunks and then create like a compare tool to go through this and compare it, and then give like a result report of what is identical and what is not, then that would be gold, right? So, I mean, this is already not bad, but we are missing the whole step with getting the same for the PDB, for the self-compiled one. I think there is nothing yet. Nothing. So, I don't know how we start with this. Yeah. I have no clue. No clue. All right. Anyway, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.